Okay, so we're going to look at the last of the notes on this idea of representing complex numbers in or form. And so, if you remember, the last video ended with us looking at an example of multiplying. Right, we multiplied two complex numbers, and we were able to represent them also as their polar representations, and realize that you just multiply their magnitudes and add up their angles or add up their arguments. And so that really is what this theorem for multiplying and dividing sort of summarizes. If you have two complex numbers, oops, I like to go a little bit. There you go. Okay, so if I have two complex numbers, and I'm multiplying them together, z1, z2, take a look what you're really doing. You're just multiplying. You're following the order of operation for the radiuses. So you just multiply those, whatever those radiuses are. And then in terms of what do you do to get the new argument, you just add the angle. Add the angle. If you're dividing out, your complex numbers, this division is the opposite of multiplying. So then I hope, it makes sense logically. Then we would divide out the radiuses. Maybe I should probably keep it in the same color code. So divide out the radiuses because that's what the operation says. And then with our arguments or our angles, we just simply subtract. So sometimes it's quicker or more conducive to do your operations in the complex number or the complex world by first putting them into polar form, by first putting them into r cis theta. And so just as some practice, and that's really what kind of the focus on this first homework assignment is just to practice that. Then when we apply it actually to solving equations, we're going to see that it's so much easier to solve equations in the complex plane using their polar representations. Okay, so for this first example, there's lots of fun little parts. So again, not too hard once you start following along. So if you wanted to watch one or two of the examples and then maybe pause the video and work out the rest on your own and then check it, that's fine too. But right here it says do W divided by Z. So if I write that as 15 cis 80, and I divide that by Z, which is 3 cis 20. Okay, so I don't have to do any kind of translation because they're already polar form. So what I'm going to have to do is follow the operation of the angle of the magnitude, which is the actual coefficients. So I'm actually going to divide those out. And then with my angles, remember, I don't divide the angles, I subtract them. So to simplify this, 15 divided by 3 is 5 cis. 80 subtract 20 is 60. Now, if you get a nice argument like that, I would expect you to write it out in A plus BI form. I'd expect you to know, that's a 60-degree reference angle with a hypotenuse of 5. So if that's 60 degrees, and again, it may not necessarily be the nicest side lengths, but opposite 60 would be x root 3, opposite 30 would be x, so 5 is in the 2x position. So I would know that this side length right here is 5 over 2, and then this length up here is 5 over 2 root 3, and it's in the I direction. So I'm not really labeling any i's here, but when I go ahead and put it here, when I say, it's 5 over 2 plus 5 over 2 root 3 in the I direction. Okay. So then I'll go to the next example, V times W. So V times W. So then my V is 4 cis 40 degrees, and my W is 15 cis 80. And again, it's already in polar form. So if I'm kind of following along, all I have to do is take the actual magnitude. So that's 4 times 15. And then I'm going to add this time the arguments 40 plus 80. So I go to my pen and I say, okay, 4 times 15 is 60 cis. And then 40 plus 80, which is 120 degrees. And again, you could actually expand this out as one way to think about this is 60 cosine of 120 degrees plus 60i times the sine of 120 degrees. That's what cis notation stands for. But if you're more visual and want to just draw out a 120 degree angle, which I kind of think about, at least in my head or off to the side of here it is 120 degrees. There's a hypotenuse of 60, and I got to be a little bit careful here because the length of my hypotenuse, which is 60, also though 60 is the reference angle there. If this is 120 degrees, then this is also a 60-degree reference angle. So side opposite that would be the x root 3. So this is 30, and this is x root 3, so 30 root 3. And again, this is the I direction. This is negative 30 because I'm to the left. So then I could express that as negative 30 plus 30 root 3 in the I direction. So there's the polar representation of that point. Okay, and then I'll just do v times z as well. Again, feel free to pause the video, fast forward to the very end if these make sense, and that way you could just check your work. But you should fill these examples out. So here I'm going to do 4 cis 40 degrees times z, which is 3 cis 20. Okay, so 4 times 3 is 12, cis 40 plus 20, which is 60. So I have a 12 cis 60 polar representation of this point. And 60 degrees is a nice argument. One could argue. Sorry, very punny today. So then 12 is the hypotenuse. 60 degrees is my reference angle. So opposite 60 would be 6 root 3. And this is 6 to make that 30, 60, 90 triangle. And again, this 6 root 3 is in the I direction, but I'm not going to write that until my final answer, 6 plus 6 root 3 I. Okay. All right, z divided by w. The fun continues. So z, we said, was 3 root 20. So we have 3, not root 20, but 3 cis 20. And then w, we know, is 15 cis 80. 15 cis 80. Okay. So again, dividing the coefficients. So 3 divided by 15 is 1/5 cis. And remember, we subtract. So 20 minus 80, which is negative 60. Now, that's the nice thing about our polar form or the unit circle approach is that negative 60, I still have that connotation of it being in quadrant 4. And so I could still think about, okay, here's our negative 60 angle with a hypotenuse of 1/5. So that's in like the quote-unquote 2x position. And let's just label that angle right here as 60 degrees. So that means the side opposite 30 would be half of the hypotenuse, which is 1/10. And then the opposite 60 would be 1/10 root 3. So I would have green this distance here. So I know that would be like 1/10. And then this distance here would be 1/10 root 3 in the negative direction. So negative 1/10 root 3. And again, that's in the I direction. So when I do that, I would say, okay, it's 1/10 minus 1/10 root 3 I. Or if you'd rather say it as like 1/10 it's just like the smartboard at school. The lower corner doesn't work. Let's see. I'm trying out my new stylus here. Oh, look at that. I can erase. How exciting. 1/10 and then minus root 3 over 10 I. Okay, so now just like in class, like, if I'm going to make, maybe I make an arithmetic mistake or simplifying mistake on the video, just shout it out. Well, I mean, don't shout it out, but let me know, go ahead and email me back and I can make a correction to it. I mean, you could shout it out. We can make it kind of weird around the people sitting next to you, but that's okay. So let's go ahead and just do example 2. And again, maybe just pause the video or go ahead and follow along if you want. Notice in this case, though, I'm taking a look at example 2. One of them is in a plus bi form, and one of them is already in r cis theta. And so I might want to convert it to r cis theta just for good practice. So I might look at that example and say it's over 6 and down 6 root 3. So if I'm over 6 and down 6 root 3 in the I direction, that's a hypotenuse of 12. So another way to represent this point is 12 cis 300 degrees. And once I do that, much, much easier to combine them. So if I'm going to do V divide by W, so V is 12 cis 300 divided by w, which is 4 cis 180. So then I could divide 4 by 12, and I would get 3 cis, and then I subtract 300 minus 180 is 120 degrees. Draw your 120-degree reference angle, sit you over here in quadrant 2, hypotenuse of 3. So I guess I'm really making you earn your keep today with these fractions, because if this is 60 degrees right there, so 3's opposite 2x, so opposite x would be 3 over 2 in the negative direction, and that means this up here would be 3 over 2 root 3, that's the I direction, so this right here would be 3 over 2 root 3 in the I direction. And again, I'll include that when I start to write the number. So I could say, okay, so we'll go back to red, and we'll say this is equal to negative 3 over 2 plus 3 over 2 root 3 in the I direction. Now, a little bit of a foreshadowing into a video that's up and coming. Be really careful that this I doesn't get trapped under the root 3, because we're actually going to figure out, well, can we simplify this? What if the root I did get trapped there? Or what if I said, well, what is the square root of I? We're actually going to figure out what that is. And we're going to be able to say, well, that's more than just the square root of the square root of negative 1. I mean, that's so silly, right? That's so algebra 2. But we're going to make sure we know how to find what is the square root of I. So again, that's kind of up and coming. A little foreshadow if you watch the video, a little extra nugget there. So let me erase that, and there, look at that. There we go, gone. But let's go ahead and do our last part of V times W. So we will go ahead and draw, I guess here, V times W. So we have 12 cis 300 times, and then we'll do 4 cis 180. 4 cis 180. So 12 times 4 is 48. Cis 300 plus 180 would be 480 degrees. And so then again, you could draw 480 degrees, which is clearly more than one. Oh, look at that. Another example. I thought it was our last one. Bonus problem. So I could go ahead and draw that. So 480 degrees. So here's 360, which means I need to go 120 degrees more. So there's my angle with a reference angle of 60 sitting inside quadrant 2. So it's really the exact same angle there. So I already know what the x2x x root 3 is, but this time I have a hypotenuse of 48, which makes it a lot nicer because then I can, then I know that this side is 24 in the negative direction, and this is 24 root 3 in the I direction. So I could say that's negative 24 plus 24 root 3I. Excellent. Okay. One more example, I think, unless there's more hidden down there. Same idea. It's sort of mixed. One of them is a plus bi. One of them is r cis theta. So I might want to convert this one to its r cis theta format. This looks like a 45, 45, 90 triangle sitting in quadrant 2. So 50, 50. This looks like 50 root 2 would be my hypotenuse. And so then that would be 50 root 2 cis 135 degrees. So if I'm going to do V divided by W, the first thing I would do would be 50, extend that a bit. So 50 root 2 cis 135 degrees divided by 5 cis 15. And then remember, we just divide these out. So that's 10 root 2 cis, and then we subtract 120 degrees. We could draw a 120 degree angle, 120 degrees, hypotenuse of 10 root 2, and that's the 2x position. So then the x position, if this is a reference angle of 60 degrees right here, doesn't look like it, but that's 60. That means that the base of our triangle is 5 root 2, and it's negative. And then this is 5 root 2 in the root 3 position, which is root 6. So then I'd say, okay, it's negative 5 root 2 plus 5 root 6, because you just multiply those square roots in the I direction. Okay. It looks like the last one, I hope it'll be, is to multiply the two together. So we go ahead and multiply 50 root 2 cis 135 times 5 cis 15. And so I'm going to multiply 5 times 50 to get 250 root 2 cis, and then we just add 135 and 15 to get 150 degrees. So now 150 degrees is a reference angle of 30 in our, that's a little exaggerated, but it's okay. A reference angle of 30 degrees in quadrant 2. My hypotenuse is 250. So this is 250. Oops, I thought I changed the color. 250 square root of 2. So that means that the side opposite 30, which is here, would be half of that distance, so 125 root 2, and that's in the I direction. And then again, that's our 30-degree reference angle, which means this here would be 125 root 2 in the root 3 position. And it's negative, so it's negative 125, the square root of 6. So then I can write my number as negative 125 root 6 plus 125 root 2i. Okay, so those two videos, again, hopefully you follow along in the notes. Maybe you're able to see a couple of examples worked out and do the rest yourself. That's fantastic. Now you have enough, in terms of notes to complete those homework exercises, and then once that's finished, you can work ahead or wait for the next day to do, the next video.